What's up guys, hello and welcome to a new episode of the Path to DevOps series. I am Shiki and today we're going to continue bettering the Helm chart that we created last time. We're also going to use it to deploy to an AKS cluster, and then I'll show you some cool features of Helm inside of Kubernetes. So if this sounds fun, let's jump straight into business. The first item on today's agenda for me is to make sure that you know where to find the materials to follow along. And you can do that by accessing the GitHub account, which will be linked down below. And you will find everything you need on the feature/adding Helm branch. This is the Helm chart, which we created from scratch in the previous video. And we're going to use this for all three microservices today. The second point is to make sure that all three deployment pipelines for both APIs and for the front end are modified and can use the Helm chart to deploy with it. So in order to do that, I've added the changes here in pipeline deploy.yaml. And basically it's the recursive search here in the path to manifest variable. And in the end, we're using Helm template and Helm upgrade as commands. So just make sure that for you, cart API has these changes. So both the manifest is searching recursively for values.yaml and it's using Helm template and Helm upgrade as deployment commands. The product API does the same things, as well, and the front end uses the same changes. Now that we've made the changes in the three YAML pipelines, and this is a point I want to stress on and we're going to tackle in a future video, I don't like the fact that when I need to make a change to the pipeline, I need to make the change 3 times, once for each pipeline. So in the future, we're going to employ something called templates for the YAML files, and this is going to ease our work a lot in the future whenever we need to make changes. But that's a topic for another video and just a small spoiler today. Right now, all we need to do after making those changes is to trigger the 3 pipelines, which I have done a few minutes ago. And we can actually query Kubernetes by doing the helm ls -n for namespace and Shiki namespace. Like this. It's the same result. And these 3 are called releases. So the Helm chart was applied 3 times, each time with a different configuration, and in the end we have this metadata here. Basically each release contains information about all that's required to run that application. And what's nice about Helm is that you can actually you use Helm and you see the available commands, and for example get will download extended information of a named release. So if I was to do Helm get cart API -namespace Shiki ns, it will tell me that it's not enough because I also need to use a sub command, and we have all hooks, manifest, notes, and values. I just want to get all so that you see what a release contains. So let's do that. And voila, this is the answer. So first things first, you will get information about the release, the name of the release, cart API, when it was last deployed, the namespace it was deployed in, the status, the revision. Revision 1 means it was deployed only once. And whenever you redeploy on top of it, it will increase the revision counter. And cool hack is that you can actually roll back to a previous revision. And I'll show you why in just a few moments. We also have the value file, which was computed in the pipeline. And as you can see here, it had everything replaced by the pipeline replace token logic. So this is basically how it looks like. And then we have a service YAML, which is this template right here. And we also have the deployment YAML. And I can already see we're going to have some problems with the APIs because the values weren't properly replaced. We didn't do that last time. So I'm fairly certain if we do kubectl get pod namespace Shiki ns, we'll see that the backends, so cart API and product API, are crashing and just restarting. It's only the front end that's running successfully. Okay, and again, the reason for that is we don't have credentials to connect to the database. We don't have the URL. Let's actually see that. So if we do kubectl logs and we copy the name of a pod and in namespace Shiki ns, yeah, you will see here at the end we have errors, and it says here URL must start with JDBC. And obviously that's not happening because when we created the Helm chart, yeah, we omitted to actually give this replace token logic here. Now, what we can do, there are actually three things we can do. And let's look at the Helm chart so that I can talk to you about them. The first and the easiest option would be I just create a new entry in the value.yaml file. Yeah, so in here we just create one new key value pair for each of these, and instead of having this replace tokens here, because we're not doing a replace token on the deployment.yaml, that's not the purpose of a Helm chart. We're only doing replace token on values.yaml because this is the entry point to a chart, and everything that's variable in the templates should be exposed to values.yaml and should grab their values from there. Okay, so the option number one, let's do it like this for you to see, would be to create a new key, something like dot values dot spring data source underscore password. Yeah, so this is value number one, which looks something like this. Now another option would be for us to make this pretty smart. Yeah, so instead of actually having all the environment variables declared in here, yeah, you would actually have your environment variables injected from the pipeline. So in here we would have some sort of logic, something like for each key value in values.yaml, just output everything you have here for me. Okay, everything that's necessary, just make it happen. Okay, and basically this will allow us to add different subsets of environment variables for each microservice. So if cart API and product API need different variables, we can actually do that. We don't need to hard code everything in every deployment template. So in order to do that, let's write the logic for this feature. We decided to go for the more advanced dynamic logic, which means we won't have these environment variables hard-coded inside the deployment template. We will, however, keep them in the values.yaml file. Yeah, so let's create a new key called extra env. This is a good name in my opinion. And let's just indent this appropriately. And what we want to do now is basically say for each of these, yeah, I want to add a new entry here. Okay, and obviously I don't know the syntax by heart in Helm, but if you search through the official documentation, just like I have, you will find that range is probably the right tool to use here. Yeah, so basically you will range through two custom created variables. One is the key and the other one is the value, and you will take those two from your values property, which in our case will be .values.extraenv, and then you will put your logic in here. So in our case, if I'm to think about it, it would look something like this. Yeah, so env and colon, and then I'm just going to appropriately indent everything, and we're going to say range. Yeah, so let's put this here, range, and then we will define two variables. One will be the key, so one will be the key and the other one will be the value. And this is the syntax, and these will be inherited from values.pizza toppings. In our case, it's going to be inherited from .values.extraenv. There we go. And I think this looks nice and crisp. Yeah, and then we will actually, this is the way we should indent it. This is the actual logic. And in here, we need the end statement. Yeah, so let's put end here. Okay. This looks good. And now we just need the logic right here. So in our case, what's the logic? Well, basically we need name and then value. So let's copy and put this here. Name and value. Yeah. So in here it would be $key, and in here we would need dollar value. Yeah. So this is how it should look like. Now, obviously, I need to put a space in here, and also I need to check the indentation, and yeah, the indentation is right. Now, the only other thing I need to make sure of is in the range, we're looking at key and value. In our case, this is the key and this is the value, and that's not exactly how I want it to look. So I will actually have this custom logic here, okay? And I hope this makes sense for you guys. Yeah, so we're creating custom key value pairs, and for each of these pairs, we are dynamically inserting the environment variables into the deployment using this range logic. So let's test this. Let's open the terminal, yeah, and let's do helm template tools barbart. Yeah, so this is how it looks. And now if we look here, you will see that we got exactly the same result as before, but the difference right now is we have nothing hard-coded inside of the deployment.yaml, and we are actually surfacing these replace tokens inside of values.yaml. Okay, so right now when we do the replace token in values.yaml, they will be replaced in here as well, and the microservices will inherit this password, username, and URL so that they can connect to the database accordingly. Everything that's left for us to do right now is to trigger cart API and product API one more time after we've pushed the Helm chart, which I've done that already off camera. And we will wait for the deployment to finish. Yeah, so cart API is the one that I triggered first, and as you can see, it's already running for 9 seconds, and we're now waiting on it to deploy to AKS. Yeah, create a new revision for our cart API release. Let's see how it fares so far. And as you can see, okay, like I said, when we look at the deploy to AKS step, you will see that the password got replaced with a sensitive value because obviously it's a secret in the variable group, and the URL got replaced successfully, and the Spring data source username is also a secret value, so that also is starred out. Yeah, but I think the most important part is when we will do kubectl get pod in the namespace of ns, you will see that it's now running for 47 seconds without a restart and without a failure. And if we do kubectl logs in the namespace, we should be able to see that it started successfully. Yeah, so the application no longer throws exceptions. It started and it's now running. Okay, so now that the pods look healthy, let's access the front end as well and see that everything is tied up together. The front end can communicate with the backends and they're up and running. So kubectl get service namespace ns, and this is the public IP of the front end. I'm going to copy that and let's access it. Yeah, and as you can see, we're getting the images and we're getting the product information from the product API, and this is a pop-up which appears as a message from cart API. So now we're able to use our stack of 3 microservices and we have deployed it through Helm. Now, before we close the video, let's talk a bit about Helm's benefits. As we've seen a few minutes ago, if we use the helm ls command on a certain namespace, you get all the releases in that namespace. Now, if you look closely, you'll notice that cart API and product API are on revision 2 right now because we had to make the change in the chart. We had to expose those environment variables which contained the database credentials in the value file. And that change is going to also be added to GitHub at the end of this video. Unfortunately, I will not add this in the same branch called adding Helm because I want you guys, if you follow along, to make the same mistakes as I do in order to learn from them. Okay, this is the reason why I didn't design the perfect Helm chart from the start. DevOps is an iterative process where you learn from the feedback loop and you improve upon the mistakes you make. If you don't fail, you don't improve. Yeah, no one's perfect. So I will create a new branch which will be called something like hotfix and something Helm related, but you will find the link to that branch in the description of the video. So don't worry, you can copy the new version of the improved Helm chart in there as well. Now, back to our business. What I want to say by revision number 2 here is that Helm actually keeps track of your history of releases, yeah? And if you do kubectl get secrets in the namespace Shiki ns, you will notice that Helm uses Kubernetes secrets in order to keep track of your versions. Yeah, so for cart API you have version 1, and this is the secret which contains this information, and it was created 34 minutes ago. And then you have version 2, which was created 6 minutes ago, or a bit more than 6 minutes ago, and this is the current version which is running. Yeah, and basically if I wanted to roll back to a previous version, I am actually able to do that. Yeah, so you have the Helm rollback command which rolls back a release to a previous revision. Yeah, so let's Helm rollback, let's see. Yeah, and it says here it requires at least one argument and it needs the release name and the revision. Yeah, so basically if I say Helm rollback cart API 1, this will roll back my cart API release from revision 2 back to revision 1. And let's do that for learning purposes. Even though revision 1 is broken in cart API, let's see what happens. Sorry, I did not mention the namespace. This is also important, obviously. And there we go. Rollback was a success. Happy helming. Now, what do you guys think happened? Well, if we do Helm ls, you will see that now cart API is on revision 3. It's not on revision 1. Okay, so it doesn't just roll back by deleting everything. No, it creates a new revision which contains the same information as the previous revision, but you're actually moving forward in terms of revision values. Now, if we look at the pods, you will notice that cart API broke. Yeah, it's now restarting and it will keep restarting because it keeps failing. And the reason why this happens is because if you remember, revision 1 of the cart API did not have the database credentials. Okay, so this hotfix is from revision 2 upwards. So we can obviously fix this by running the Helm rollback command one more time, and we're going to roll back to revision number 2, which is the successful one. Until then, let's check the browser, and if we do this now, you will see that cart API isn't popping up anymore. When you click the buy now button, you are not getting the pop-up anymore because obviously revision number 1 was flawed. Yeah, but now we rolled back again to revision number 2, and if we look, revision number 2 is actually revision number 4 now. As I said, we increase in revision numbers, but 4 has the same contents as 2. Yeah, as you can see here, when we rolled back to 2. So right now, if we're looking at the pods, you will see that they are basically healthy for the past 41 seconds or so. Yeah, no restarts, no nothing. So finger crossed, let's just refresh one more time. And there we go. And when I hit buy now, I'm still not getting the cart API pop-up. And I think this has to do with caching. So honestly, kubectl delete pod namespace Shiki NS, and I'm just going to delete the front ends so that they can reconnect to cart API and to product API again. Let's wait for them to start. Let's do a refresh. And now, as you can see, the pop-up appears. Okay, so sometimes when the applications are not exactly designed to be Kubernetes ready, and in my case, because I'm not a developer, I don't know programming that well, I wasn't able to add a lot of logic and functionality in order to make these applications Kubernetes viable. I think the front end hanged on reaching the service for the cart API, which is why we weren't getting the pop-up. But now I restarted the pods connected to the cart API and to the product API once more. And as you can see, we're getting the information from the product API and also the pop-up from the cart API. So now everything is fine. And we now leverage the power of Helm in order to have history regarding our releases, and this will be immense help for someone who tries to deploy something to production, because obviously you want to have a history of what happened and you want to have the capacity to easily roll back, and in case you deploy a faulty release, you want to be able to migrate back to a revision which was approved and working. This is it for today, guys. I really hope that you see the value that Helm brings to the table, the possibility of maintaining a history, rolling back to a previous revision. All of these are potent mechanisms which can help your production environment, and not even production environment, any environment, be a lot more agile and more resilient to failures. So I will see you next time in a future video, and until then, I wish you a great day wherever you are. Thank you for your time. Cheers.